Friends, we all have heard the story of the thirsty crow, where a thirsty crow comes across a pot that contains only a small quantity of water. So it dropped stones into the pot to raise the water level so that it could drink water. And the moral of the story was, where there is a will, there is a way. Guys, knowingly or unknowingly, that crow applied mathematics over there. The simple logic is, when it was throwing small stones into the pot, the stones drowned and the same volume of water rose up. As soon as the number of stones increased, the water level also increased and it came up to the brim of the pot. So guys, let's try to play with this logic and suppose that if a similar type of exercise would have been given to us, like a cylindrical glass with radius 3 cm and height 12 cm is half filled with water, and some identical marbles of radius 1 cm are kept aside. So tell us the number of marbles that will be required to raise the water level at the height of 12 cm. For instance, if additional information is given that one marble increases the water level in the glass to a height of 0.15 cm. Can we now be able to calculate number of marbles required? Let's see how we go about it. Here a glass of 12 cm is half filled. It means the water level is already at the height of 6 cm and the remaining 6 cm has to be filled. So consider we need x number of marbles to raise the water level by 6 cm. Therefore, 0.15 into x is equal to 6, which implies x equals 40. Therefore, we say that we require 40 marbles to raise the water level and completely fill the glass. Right? Friends, if this additional information was not given to us, then how would we find the number of marbles? Are you all equally curious to know? See guys, that crow was not as smart as we are, but at least it knew that the water level was increasing and it kept on dropping stones till it could get the water. Being an intelligent species, how will we find the number of marbles by only knowing the radius of the marble and the dimensions of the glass? Let's find out together. You know friends, when the marbles go deep inside the pot, they occupy some space. And that's why the water level rises up. And that to be in the same quantity as the space occupied by the marbles. And we have already learned from our previous sessions that the space taken by any three-dimensional object is the volume of that object. So let's cross-check whether it is really 40 marbles or not. So first of all, we will calculate the volume of empty portion of the glass, followed by the volume of a single marble. And then we will divide the volume of empty portion of the glass by the volume of a single marble. That will give us the number of marbles required. So let's do it one by one. We know that the volume of cylinder is calculated by the formula pi r squared h, where r is the radius and h is the height. Here, radius of the glass is 3 cm and the height of the empty portion is 6 cm. So by putting the values of parameter into the formula, we will get 54 pi centimeter cubed. Now the second step, volume of a marble. Volume of a marble is calculated by the formula 4 by 3 pi r cubed. This is the general formula used to calculate the volume of a sphere. And marble is also a spherical object. We will also discuss why do we use this formula to calculate volume of a marble, or you can say a spherical object, just after a few minutes. First of all, let's calculate the volume. So its volume will be 4 by 3 pi centimeter cubed. Now let's go to the third step. Here we will divide volume of empty portion of the glass by volume of a marble. So after calculation, it will give us 40.5. That means it actually need 40.5 marbles. Or you can say that we need 40 and half marble. So we are getting an almost equal answer. So guys, this was the logic about rising water level. And whenever there is logic, there is mathematics. Let's move forward and see how we have got the formula 4 by 3 pi r cube to calculate volume of a sphere as mentioned above. So to begin with our derivation, consider this sphere is made up of 100 pyramids with tiny bases. So we can say that the volume of this sphere is equal to the volume of 100 pyramids. If we cut open the sphere, we can see that the radius of the sphere is actually the height of the pyramid. And as we all know, the radius of the sphere is same throughout. Therefore, we can conclude that height of all pyramids is same. But when we talk about the bases of these pyramids, they form the surface area of the sphere. But unlike height, they may differ in their areas. We know that the volume of a pyramid is calculated as 1 by 3 into base into the height. And we have 100 such pyramids with different bases. So let's consider the first pyramid have base B1. So it can be written as 1 by 3 into B1 into H, where H is the height of the pyramid. Now this height can be replaced by the radius of the sphere. Since height of the pyramid and radius of the sphere are equal and are constant. Similarly, for the second pyramid, we can write 1 by 3 B2R. For third, 1 by 3 B3R. And so on, we can write for the 100th pyramid 1 by 3 B100R. Now, 1 by 3 and R can be taken common. So the next step will be 1 by 3 into R into the bracket B1 plus B2 till B100. Since addition of all these tiny bases of the pyramids together form the whole surface of the sphere. So instead of this, we can write the surface area of the sphere, which we have already learned in our previous session, which is 4 pi r squared. And therefore, we get the formula as 4 by 3 pi r cube. So this is how we derived the formula for volume of a sphere. And just as in our previous session, we derived surface area of a hemisphere with the help of surface area of a sphere. Similarly, we can also find the volume of a hemisphere by using the formula of the volume of a sphere, where we divide volume of a sphere by 2, which will give us 2 by 3 pi r cube. Also in the same way, by dividing it with 4, we will get volume of the quarter part of a sphere, which is 1 by 3 pi r cube. Guys, please keep in mind that things are so logical and easy to understand. For each interesting thing, we need a little bit of concentration. So see you in the next session with some questions on surface area and volume. Leave your valuable comments and please do subscribe to our channel. Thank you.